Sir, good morning, sir.
Good morning, ma'am. Good morning.
Good morning, sir. Shall we start, sir?
Yeah, we can start. I'm ready, sir.
Okay. Ma'am, Viji ma'am?
Yeah, yes, ma'am.
We'll start.
Yes, ma'am. So, a very pleasant good morning to one and all present here. On behalf of Ramco Institute of Technology, Department of Computer Science and Engineering, I welcome you all for the International Conference Day 2, Smart Technologies and Applications 2022 Invited Talk Session. So I welcome you, Dr. Prashant R. Nair, sir, Vice Chairman, IQAC and Associate Professor, Department of Computer Science and Engineering, Amartya Vishwa Vidyapeetham, Coimbatore. I welcome you, sir. I welcome our beloved Principal, Dr. L. Ganesan, sir, and Vice Principal, sir, Dr. Raja Karnagaran, sir, and Organizing Secretary, Dr. K. Vijayalakshmi, ma'am. And I welcome all the participants to this session. Now I will introduce our today's chief guest. Dr. R. Prashant Nair is working as Vice Chairman, IQAC and Associate Professor in the Department of Computer Science and Engineering, Amartya Vishwa Vidyapeetham, Coimbatore, India. He has over 21 years of teaching, research, mentoring, training, consultancy, and academic administration experience. He has taught in academic programs in USA and Europe at University of California, San Diego, and Sofia University, Bulgaria, as an Erasmus Mundus Fellow. He has written 6 books, edited 2 books, 1 book chapter, and over 50 publications in reputed journals, books, and conferences. He has mentored student teams which have won premier international and national competitions like Smart India Hackathon, Rajasthan Hackathon, TCS Digital Twin Challenge, and represented India as a part of national hackathon team for Singapore India Hackathon, and felicitated by Honorable Prime Minister of India, Shri Narendra Modi. He has also been ranked as the top innovation mentor in India by Atal Innovation Mission and coordinates AM activities at Tamil Nadu as regional mentor of change. He has been serving as the chairman, vice chairman, and coordinator of Amartya Deemed University's internal quality assurance cells since 2009. He has coordinated 3 cycles of NAC accreditation, NBA accreditation, NARF rankings, and also served as UGC nodal officer for university. A very short after speaker by conservative estimates has addressed above 15,000 students and trained 10,000 plus faculty on technology, innovations, professional bodies, and quality aspects of higher education. I welcome you, such an eminent person, for our today's invited talk. I welcome you, sir. Now I hand over the session to our chief guest, Dr. Prashant R. Nair, sir.
Thank you, the respected principal, vice principal, and convener for the conference, Dr. Vijayalakshmi, dear participants from all over India. At the outset, I'm very happy to be part of this invited lecture series of the International Conference on Smart Technologies and Applications, organized by Ramco Institute of Technology and supported by several bodies. Am I audible?
Yeah, sir.
Yeah. Okay. So let me just share my slides and I'll. Is my slide visible?
Yes, sir.
The slide is visible, right?
Yes, sir.
Yeah. So thank you for this opportunity to talk about a very exciting technology, that is the Internet of Things, for this topical conference on smart technologies. So generally speaking, IoT is the heart or the pillar of all smart technologies, and this is very important and topical in terms of the future scope when we are moving on to an era of the 4th industrial revolution. So the 4th industrial revolution. So we know about the four industrial revolutions, starting with the steam engine, which happened around the fag end of the 18th century. Then at the beginning of the 20th century, the Ford Automobile Company created this factory automation and mass production, mass customization of automobiles, and that spurred the second industrial revolution. The third industrial revolution, which started around the late middle 70s and continued till the dawn of the millennium, primarily leveraged on the microprocessors, the miniaturization of electronics, VLSI, which resulted in a lot of advancements in this field in terms of automation and devices which run on these chips and microprocessors and so on. So today we are now in the throngs of a fourth industrial revolution. It is arguable, people say that the fourth industrial revolution has given way to the fifth industrial revolution. But the fourth industrial revolution is one where we have seen, smart manufacturing becoming the order of the day. Now, the concept of the Industry 4.0 happened in Germany at around the same time. The Smart Manufacturing Leadership Coalition in USA, which consisted of all the major the big three in America, that is Chrysler, General Motors, and Ford. All of them were also moving towards the smart manufacturing. And the general idea about the Industry 4.0, which was coined in Germany, but it is synonymous to the smart manufacturing in the USA and other places, is use of all high-tech devices and which have the genesis or the seed of the cyber-physical system. And what is a cyber-physical system? A cyber-physical system means it's a mix of physical devices, physical equipment, physical paraphernalia, along with virtual devices, virtual controls, and so on. And what is powering these cyber-physical systems, which is the base of the Industry 4.0? It is nothing but IoT. IoT is the base of that. It is the pivot, so as to speak, because in cyber physical systems, it's basically there are physical processes. There can be a factory that you are doing automation. There can be a car that you are controlling remotely. All these physical processes are basically monitored through a virtual means, and that virtual copy, the transmission of data to that virtual copy, happens through the IoT. So the IoT is a communication channel by which the cyber world and the physical world are bridged together, and thereby they cooperate and collaborate and communicate in the real time between themselves and between humans. Now, having said that, the Industry 4.0, even though the pivot, the Industry 4.0 runs on cyber physical systems, yes, and the pivot of the cyber physical system is the Internet of Things, the IoT. But at the same time, Industry 4.0 also runs on some other technologies like 5G, artificial intelligence, machine learning, sensors, AR, augmented reality, virtual reality, robotics. So these are some of the building blocks. So I'll quickly again sum up what I'm trying to say in this slide. Industry 4.0 is here to stay. Industry 4.0 is moving forward. The pivot or the bedrock of Industry 4.0 is cyber physical systems, and it is IoT that acts as the pivot of the cyber physical systems, whereby the physical and the virtual worlds communicate over the IoT and the sensors. But there are other very important technologies as part of Industry 4.0, namely robotics, augmented reality, virtual reality, machine learning, artificial intelligence, 5G, and the like. Now, as I mentioned, people are now talking of whether the fifth industrial revolution has started. There is a discussion going on that, have we come out of the fourth industrial revolution, and has the fifth industrial revolution started? Well, the answer is a partial yes. Now, if you see these devices are all part of our life today. I cannot even imagine having a phone other than an iPhone. I have an iPhone 13. I cannot even imagine changing my phone, because for the last decade I've been so happy with an iPhone. But in 2006, this iPhone never existed. There was nothing called iPhone. I cannot go for classes without my iPad. It's become a habit. Without an iPad, I cannot take physical presentations. It never existed in 2006. Kindle. People use Kindle for reading. When it was not there in 2006. 4G was not there. Uber was not there. Android was not there. Airbnb, Oculus, Instagram, Snapchat, WhatsApp. Now, many of these so-called game-changing technologies were not even there in 2006. They were not even there. And today they are so pervasive, they are so ubiquitous, so available everywhere and anywhere. And interestingly, just see this trend. The telephone took 75 years to reach 100 million customers. The internet or the web took 7 million customers. 7 years to reach 100 million customers. Facebook took 4 years. Instagram took 2 years. Pokemon Go, that game, the anime thing, took 1 month. Today, I will not be surprised if an app can reach 100 million customers in a day. It is possible. It may even become 100 million in a day or a few hours. It is possible. That is how the technology landscape has changed. And that is why I told you, we are moving on. Are we moving on to a industry 5.0? I have already told you the bedrock of industry 4.0 is the cyber physical system. There are physical systems, virtual systems, they collaborate with each other, they communicate with each other, they monitor the physical processes. The operations are monitored, coordinated, controlled, integrated by the virtual means. The physical processes are happening. Today, we are talking of cyber physical systems in the metaverse. I'm sure you heard about this metaverse. Have we reached the industry 5.0? Have we reached the era of the metaverse where a physical world and a virtual world are existing hand in hand? Digital twins are there hand in hand. Actually, we are slowly moving on to that area. We are looking at digital twins. We are looking at the metaverse. We are looking at the physical world being, merged with the virtual world. And to a large extent, we are seeing many of us are now talking online, right? Many of the seminars or conferences are online. Just think of a situation. Believe me, this is not far away. I am now I'm taking this keynote address for this international conference. If I have a lab session today, maybe my digital twin, my avatar maybe will do the evaluation of the lab online submissions of my students at the same time when I have a conflict. These are not things that may happen in the next generation. It may happen this generation itself. So are we moving towards that industry 5.0 where we are going to see this collaboration of the metaverse, the physical world and the virtual world happening simultaneously, hand in hand, collaborating with each other, complementing each other? We do not know, but the future sounds very exciting, very, very exciting. And IoT is going to be the pivot for this cyber physical system. I already told you all these things. Now, what is the Internet of Things? So this is only an overview and a presentation on where all the domains are, what are the challenges and so on and so forth. Now, in terms of IoT, Internet of Things, things is a physical or a virtual thing, and each of these things, the physical and the virtual thing, is able to perceive and act. It is able to understand, perceive and act. It is able to learn, sense, act and operate. So a thing can be a physical thing, a person, environment, things. A thing is a device. The device can learn, the device can act, the device can operate or do its functionality, a device can sense. That is the logical view of an IoT device, in an Internet of Things device. Every physical and virtual thing in any environment can perceive and act. Now, how does it perceive and act? There are supporting devices, there are algorithms, heuristics that create a cognitive loop whereby these intelligent building blocks are able to perceive and act. There is a cloud storage, a lot of easily, seamlessly, any amount of data can be stored. And the data can be indexed, collated, curated in such a way that is easily available and accessible. That is the learning aspect of the IoT. Now, the acting aspect in IoT, it is through actuators and devices whereby it is able to do things. It is able to do control, execute actions. It is able to operate through associated hardware, software like the actuator. And how it is being sensing, it is through the sensors. There are dime a dozen type of sensors that are available. Pressure sensor, gas sensor. You want to have a bad smell, foul odor, there is a sensor for that. There is a pressure sensor, gas sensor, soil sensor, so many sensors. So as to speak, this cognitive loop of learning, acting, operating and sensing is happening through various supporting associated hardware and software like the sensor and the actuator, and of course supported by algorithms, heuristics, machine learning, cloud and so on. Now, how did IoT come through? IoT basically is an offshoot of am I audible? Am I audible? I'm hearing some sounds. Okay. Is the slide still visible?
Sir.
Okay.
Yes, sir. It is visible, sir. No problem, sir.
No, some sound came as if I was logged out or something. Sorry. Okay. So how did IoT come? IoT was a logical culmination of the machine-to-machine collaboration. There was communication between machines. There was a connectivity between machines. You take a network. There were two computers. They were talking to each other. You could cut, copy, paste. You could delete files. You could control each other's hard disk. All these things were happening. So there was content and connectivity in the machine-to-machine platform, machine-to-machine communication. But it was only restricted to the connectivity and the content. You could communicate with each other, you could copy files, you could exchange information, you could exchange messages, data, and so on. But this machine-to-machine communication, collaboration, and connectivity and content evolved into IoT, whereby the addition of context, collaboration, and cognition. There is a context available, a situation available, a use case available. There is a cognition. You are able to analyze, you are able to sense, you are able to discern, you are able to take decisions. And earlier, it was only connectivity. You could cut up a copy a file from one computer to another computer. You could do the vice versa. But there was no joint decision making. That collaboration was not there. It was a half duplex line. You are doing one-way or two-way communication, but there was no discussion, dialogue, or collaboration. So the machine-to-machine service platform, which only had connectivity and content, evolved into IoT with the addition of the collaboration, the context, and the cognition. And the cognition perhaps is the most important aspect. You are able to sense, you are able to discern, you are able to take decisions. And this is a picture, how the M to M, machine to machine, everybody was communicating to each other. Now that has gone. Everything is communicating to a common server, which could be on a cloud, which could be on the anywhere. It could be a server, or it could be on distributed. It could be on a cloud, wherever. And if there is not only that, there is a decision-making paradigm also. You are able to sense using sensors. You are able to use actuators and do things. All these control. You could be sitting in San Francisco and you can you can control your your refrigerator. You can control the air conditioner at sitting 100,000 miles away. It's possible, right? Okay, so now I have already told you IoT or Internet of Things. Nowadays, people even say Internet of Everything. IoT, some people say IoE now. Internet of Everything. Everything is becoming intelligent. It was only things. It was devices like mobile phones, computers, tablets, watches. Now everything and anything. Your clothes can be smart. Your spectacle can be smart. Anything can be smart. The clothes that you wear can be, the shoes that you wear can be smart. The pacemaker in your heart can be a smart device. So today we are moving on to an age of Internet of Everything. Anything and everything is covered. And I don't need to tell you anything and everything. Applications are galore. It used to be only computers, sensors. Now things could be people, actuators, refrigerators, TVs, vehicles, mobile phones, clothes, food, medicines, books, anything and everything. We can put them into three buckets: people, human beings, machines, and information. These are the three buckets that we can put. So anything and everything is now on the internet. Any person, any machine, any device, anything can be made intelligent, made smart through the IoT device. I already told you all these things. I've already told you all these things here. And now coming to the domains. There is not a single domain, there is not a single area that has not been touched by this pivot, the IoT pivot for the CPS, the cyber physical systems, which is driving the industry 4.0. There is not a single area, whether it is smart healthcare, smart homes, smart shopping, retail, smart energy, sensors, devices, grid, smart manufacturing, the industry 4.0, smart car, smart mobile mobility, smart buses, smart trains, logistics and manufacturing, smart media. Every single domain has been affected. Every sector, every vertical, every industry has been affected. And that is why Industry 4, we are talking of Industry 4.0 moving away, and the Industry 5.0 and the metaverse taking over. We have come to that state. Now, some fundamental concepts with respect to the overview before I move on to the challenges of IoT. The definition of IoT as per IEEE is very interesting. A network of items, each embedded with sensors which are connected to the internet. I've already told you all these things. People can be connected to things. Things can be connected to things. That's also possible. Okay. Now, coming some to the technical aspects of IoT, a quick overview on the protocol stack, the 7-layer protocol stack. We are aware of the ISO OSI model for networking. It's a very common thing, but then at the same time, the ISO OSI model is a very intelligent, interesting thing. Similarly, the IoT has a 7-layer stack of protocols, and quickly we'll go through these things. It starts at the lowest level, the physical layer, with the physical devices and the controls, the sensors, which some of us even say it is the edge computing. Edge computing, or the edge, not the edge computing, the edge. in terms of the last mile devices, the things in the IoT, which could be your sensors, devices, your machines, your books, your clothes, your mobile phone, your computer, your tablet, your laptop, and so on. The second, or the network layer, the next layer is the connectivity layer, which consists of the communication and the processing units by which these things or devices are talking to each other. The third layer is the edge computing or the fog computing. Many people confuse this edge, fog, and all. Edge computing is the data element analysis and transformation, where you have unstructured data. Here, this can also be known as the big data layer. So much of data is there. This is actually going to be the biggest challenge of IoT lies here in this edge computing, this fog computing, because there is so much of big data available. That's the biggest challenge. I'll come to that. And this challenge brings about a kind of so much of data, and the problem is all this data is in different formats. So now you need to store the data, that is one level higher, accumulation of data. Then you need to clearly use the data, clean up the data, do a pre-processing, aggregate the data, that is the fifth layer. And then you come to the layer where the data has to be mined, has to be analyzed, analyzed and put into drill downs and drill downs and menus and dashboards, where we are able to use and collaborate. So it's a very logical flow in terms of the IoT protocol or the IoT reference stack. Starting with the devices, the physical devices, the sensors, the actuators, on the computers, on the books, or on the clothes, or on the phones, and so on. Second layer is the communication elements by which these devices are communicating with each other. The third element is the biggest challenge, the fog or the edge computing, whereby so much of data is coming from all types of areas, different formats, different ways. Then the fourth layer is how you store this data. The fifth layer is how you aggregate and access and clean up the data, structure the data. The sixth layer is how you analyze the data, how you mine the data. And the last, or the seventh layer, is by which you are taking the process, you are getting the outcomes in terms of the collaboration and the process. This is a very clear stack in terms of the IoT. Not moving. Yeah. Now, IoT also needs a lot of technology for communication. The communication for the technologies are needed to communicate between the sensors, between the sensor and the device, between the actuator and the sensor, between the sensor, actuator, and device, and so on. And some of the technologies that are the building blocks in terms of communication include the Bluetooth, the Wi-Fi, RFID, Zigbee, Z-Wave, near field communication, and of course 5G, 4G networks, LTE, Ethernet, and so on. Of course, maybe Zigbee and Z-Wave are no more, not NFC also to some extent have not become very popular. People are primarily using Bluetooth, Wi-Fi, or 5G, 4G networks, Ethernet, to some extent industrial RFID, but perhaps Zigbee, Z-Wave, NFC have not become so popular. All this I have explained. Okay, just I thought I will get into a couple of case studies before I move on to the challenges of IoT, which is the pivot for the cyber physical system, which is driving the industry 4.0 and the factory of the future, and manufacturing for the smart. Now, excuse me. Give me a second. Now let us just see a very how intelligent retail setup can be. You know, people say a retail or a shopping setup is all about the detail. How nicely you organize the items in the shop, in the neatly stacking them, neatly lining them so that it is so attractive, and you are able to, you want to buy. See, even though we are buying a lot of things online, all of us want to go to a shop. Even if it is grocery, we want to go and walk all down the aisle, see the items, see the options, and so on and so forth. So that personalized experience is continuing. Today we know that even though you can do any, you can watch movies on OTT platforms, you still want to go to the theater. You want to go to the mall, even though you may not be buying anything from the mall. Maybe once in 2 visits you may buy, but that at the end of the day, that's still fine. But see how the actual shopping experience can be made very excitable. While you are walking down this thing, the items are talking to you. Just imagine, the goods are introducing themselves. Hey, I am a new detergent. I just arrived yesterday. I have got this. I'm special. Just imagine now, if one of the shop floor supervisor wants to see, he's walking and he wants to take an inventory. Immediately he gets the order. Oh, somebody, I'm missing a bottle here, what happened to that? All those kind of information is possible. As a shopper enters the store, the scanners are identifying her through the clothing and the tags and the pants, shirts, and shoes, and the history of shopping is known, and that information is given to is known to the people who are standing in the shop. So as soon as you come, hello sir, I'm sure you want to replenish your Coke. You're a very common Coke customer as per our records, and immediately that person helps you. So you get a personalized experience in terms of the shopping experience. And also everything is cashless. You just need to give some swiping, or even swiping may not be even needed. It could also be biometric. So these are the kind of ways. This is of course an extreme case where shopping can be extremely smart with the application of IoT. Now another application is healthcare. You may be sitting anywhere. The doctor can tell you that you're getting a heart attack. You don't know. You're sweating a lot, right? You are sweating a lot, but you don't know that you're getting a heart attack. But the doctor sitting somewhere would have got an alert from your pacemaker or from some sensor in your body, and that pacemaker would have hit an alert, and the doctor would have got the alert on the phone, and the doctor is calling you and saying, dude, you're getting a heart attack, immediately get into call for medical help. And this can be done for any part of the body, whether it is for glucose. You need a insulin shot. If you're diabetic, an insulin shot, you don't know, you only feel sweating and tiredness, but somebody is telling you you need an insulin shot. These kind of things are possible, and it can be done for any part of the body, whether it is the eye, the ear, cochlear implants, or intracranial pressure sensor, bladder and bowel simulators. Everywhere and anywhere it is possible. So these are the wide varieties of devices. And now today in healthcare, India is talking of what is known as the technology stack, because today India stack, you go to a hospital, you get you become an inpatient in the hospital. You have a diabetes hit or something like that. You fall sick due to diabetes. You are hospitalized for 3 or 4 days. Your insulin levels are really needed, and so on. Now that hospital will give you a discharge summary. The next time you go to some other city, you have the same problem. This time you would have fractured your leg. You go to a different hospital. Now, different hospital will ask you 100 questions. What is your medical history? Oh, you have diabetes. Can you give me the discharge summary? Do you have that? Then you'll say, no, I don't have that. Then even if you provide the discharge summary, there are some formats, but the second hospital may not be able to get what they need, because The first hospital uses a different format, second hospital uses a different format. There are some minimum requirements in terms of medico-legal requirements for a discharge summary. But having said that, every hospital is using their own formats, their own computers, their own software, their own hardware, their own type of formats for discharge summary. See, this it's very difficult. Now there is a talk of having an India stack where every single healthcare provider in this country will have the same software, will have the same discharge summary, and the data and information is totally interoperable. This is the plan, and it is going to be IoT and sensors that is going to drive this. Now, I'm coming to the end of my presentation. I want to highlight this software called ThinkSpeak. Thinkspeak.com. This is a very good platform for faculty members. Many of you are faculty members, I guess, for you to give your students some IoT based projects. It's a very good tool. Please note this. ThinkSpeak. You can do questions. It's freely available. But of course, I think certain things are not only available for commercial use, but for teaching students, you can use all the devices in ThinkSpeak. You can give demos of sensors. You can give use cases. You can add, things and so on and so forth. Now, coming to the last part, the challenge. So, please make a note of this. ThinkSpeak. Thinkspeak.com. You will be able to do a lot of hands-on exercises for the benefit of your students. Now coming to the last part, the biggest challenge. There are challenges in IoT. Of course, security, that is a challenge everywhere. Privacy, challenge everywhere. Interoperability. One sensor from one company may not talk to a second sensor from a different company. Those issues are still there. But we are using Arduino boards and all. So now today, many of these problems are more or less solved. There are interoperability issues. Over-the-air upgrades, yes. Complex event processing standardization. But the biggest challenge in IoT remains the big data. Even though security, privacy, interoperability, new upgrades and developments are challenges, the biggest challenge remains the big data. The big data is a big problem. And the biggest problem is that all the data comes in different formats. Different types of formats, different types of hues and sizes and colors. Now, just to give you a glimpse of this big data, your car may have 200 sensors, and every day the car is generating 4 terabytes of data. An aircraft may have 6,000 sensors, and it is 2.5 terabytes of data in terms of the flight recorders, the cockpit recorders. You can imagine the amount of data there. Like this, we are having so much of data, and this brings us to an era of analytics. So much of data is there. Today on an average, every month, 3 billion users of Facebook are there. Almost 2.85 to 3 billion people use Facebook. You can imagine the amount of data that people are generating through Facebook. Every day, just 1 hour back, I posted something. Like that, 3 billion people, maybe not all 3 billion, but even if 1.5 billion people are posting something, you can imagine the amount of data that is generated. Every day, 12 plus terabytes of tweets are happening every day. That is the volume of data. Things are happening so fast. When your 5 plus million trade events are happening through seconds, I'm talking of stocks, shares, buying shares, selling shares, and so on, making purchases. Every second, 5 million transactions are happening. That is the velocity of data. Biggest challenge, the variety of data. you are using different format. Your audio files are your video files are .mp4. My video files are VLC, .VLC or .avi, whatever. Different. There is a variety of data. And finally, the veracity of data. Which data is trustworthy? Which data is not trustworthy? So these are the biggest challenge. And because of IoT, we need to have IoT. If IoT is the backbone of the infrastructure, the IT infrastructure, IoT analytics is the key that will help you create meaningful insights from the huge amount of data that comes. Meaning that data needs to be collected, the data needs to be collated, the data needs to be consolidated, the data needs to be curated to get, and the data needs to be mined to get meaningful insights and actionable intelligence. And that is the biggest challenge, so as to speak, with respect to the data. You can imagine all types of information, and we need to have a process of transforming that data which comes from this IoT, billions and billions of IoT devices, sensors. We need to transform that data into analysis, through analysis, and get insight, so that you are able to use the data for actionable intelligence, problem solving, and so on and so forth. This is the fundamental in terms of the challenges that are there. I close with this. This is kind of a dashboard by which you are able to get analytics. This is a marketing dashboard. The data has come from different sources, through IoT devices, through Facebook, but you are getting a dashboard with whatever data is there, what kind of analytics is there. From this you can easily find out that your which social media handle is the best. It's very clear that it is Facebook. Twitter. Twitter is getting you maximum followers, followed by Facebook, followed by Instagram. So these kind of dashboards, drill downs are possible for any thing and everything. This is again another dashboard, a Fitbit health dashboard that takes from the sensors. It gives you all device information about your health, about how much you have walked, and so on and so forth. So we need IoT analytics to analyze and examine the large volume of data obtained by the Internet of Things. The sensors, actuators, and the devices will get so much of data, and we need to analyze this. With this, I close my presentation. I will be happy to answer any amount of questions. Thank you very much to the organizers. Wish the conference all the very best. Thank you.
Sir, thank you, sir. So, dear participants, if you have any queries, you can either unmute your mic and talk, or post in the chat box. So, participants, kindly post your queries in the chat box. If you have any questions regarding this IoT. Sir, there is one query in the chat box. Yes.
Can you read it, please?
Yeah, sir. What are the challenges in IoT in data analytics?
So, see, in IoT, the major challenge I told you is the issue of having the analytics for the IoT. as I mentioned, there are so many IoT, different types of devices, different types of data, different types of sensors. One sensor from another company may not talk to another sensor from a different company. That interoperability. So primarily the biggest challenge is definitely the big data, how to handle the big data, how to have analytics out of the big data and so on. But then the other challenges are also there. There are issues with interoperability. There are issues with that privacy, but privacy it's a major concern everywhere. It's not only here. Even if you're talking of your Aadhaar database, there is a privacy concern. There is a security concern. You don't know whether it is safe. In between, we have heard that even the Aadhaar database was hacked. These are all we don't know, but there are rumors. So these issues are definitely there. The data privacy issues, the data security issues, interoperability issues. But my take is that the biggest challenge in IoT is the analytics. How to have proper algorithms to analyze this big data. Because the data has got variety, velocity, veracity, and volume. That's the 4 V's of data, right? Velocity means so much of data is coming every second. Variety means different formats. Third is volume. So much of data is being generated every day, and you have to even if you want to analyze, you have to analyze all these huge volumes of data. And finally, the veracity. Veracity means whether the data is trustworthy or not. So these 4 V's are a major challenge, and that we need to have analytics, algorithms, better machine learning algorithms, heuristics to analyze that data.
Thank you, sir. So any other participants have any queries?
So I have given my email ID. In the chat box, I have placed my email ID. Conference organizers also have my email ID. You can connect with me. I have also given my, if you professionally search, noise coming from somewhere.
Ma'am?
Yeah, so you can search for me on noise. So on Facebook, YouTube, and LinkedIn, you just search for my name, Prashant R. Nair, Prashant space R space Nair. The YouTube channel is very new, but the Facebook and LinkedIn have been there for quite some time. Any more questions? I've also put the link of the ThinkSpeak, the where you can take exercises on IoT for your benefit of students, especially in terms of lab exercises and hands-on exercises.
Thank you, sir. Thank you for your valuable input regarding IoT issues, challenges, and what all the facilities are available and what all the softwares are available, everything. It is very useful and informative session, sir. Thank you, sir.
Yeah, thank you, ma'am. Thank you very much. It's also I like change. I like a change. See, every week I have 5-6 lectures, mostly IQAC, OBE, and all. It's always nice to connect to the department. Technical thing. Actually, you didn't read something that was not mentioned in the profile. Was I used to head the CSE department in Amrita for over a decade.
Okay.
As vice chair, but that was not mentioned in the profile. Anyway, I'm just telling you that.
Okay.
Okay. Thank you very much, Vijayalakshmi ma'am. Wish all the participants the very best. Please stay in touch. I have given all my coordinates to you on the chat box. I can close. Your next session is starting, ma'am?
Yeah, sir. Next session is a session, sir.
Okay. Thank you very much.
Paper presentation, sir.
Yeah.
Yes. Thank you, sir.
All the best to the paper presenters. Thank you.
Yes, sir. Thank you, sir. Thank you for your valuable session. The session provides an opportunity for our participants to learn about the overview and what are the various challenges in IoT domain and how can we approach these challenges and all the things. The session is very informative. Thank you for spending your valuable time with us. Once again, thank you, sir. Thank you so much.
Thank you very much. Thank you.
So dear participants, kindly fill the feedback form. The feedback link is shared in the chat box. Kindly fill it.
So based on the once if you fill the feedback form, you will get the certificates.
It's a lifetime member in CSA and all. We welcome you, ma'am.
Yes, ma'am. Thank you.
Thank you. Another chairperson we have Lakshmi ma'am. She is full-time software engineer, currently associated with the firm Solaritis Technology Services, excelling in the field of Java REST API development using rules with a touch of business analysis for about 3+ years. She graduated from Domcon of Technology with a PVCSC degree year of 2018. She did her schooling from various cities, thereby gaining a lot of life experience. She taken up many initiatives that includes producing efficient and long-lasting results for high-end international clients, thereby reducing development effort by half and received remarkable compliments for the same. And a social activist focusing on nurturing the young population of our society by actively taking up issues and raising funds for multiple causes. She recently joined hands with Bhumi Fellowship in successfully raising funds for uniforms for school kids who cannot afford them, using various methods including social media campaign. She also have interest in social media blogging and enjoy reading books, creating content and writing blogs. We welcome you, ma'am.
Yeah, thank you.
Presenter, here I am dictating the rules for the presenters. So you can take 10 minutes for presentation and 5 minutes for query. And feedback will be posted end of the session. Okay. First, now I call upon the paper Prediction of Lung Cancer Using SVM and Random Forest, paper ID 205, authors Kavi Bharati, Dr. S. Sumita. You can share your screen, ma'am.
So, good morning, everyone. Ma'am, whether I'm audible?
Yes.
Yes, you are audible. Yeah. Please go ahead. I'm not able to hear any audio now. Is it only me again?
Ma'am, whether my screen is visible, ma'am?
Yes, yes, yes.
So, yes, ma'am. So, good morning, everyone. And my topic is about prediction of lung cancer using optimized RF algorithm. Actually, I'm very happy to introduce here myself. So, thank you for this wonderful opportunity, ma'am. So, myself, Kavi Bharti, and my guide is Dr. J. Sumita. And we are from SNS Rajlakshmi College of Arts and Science. And my presentation is on prediction of lung cancer, and here we'll be seeing about introduction and what are the materials and methods and I have used, and the results and discussion, and the last part will be on conclusion. And now my abstract of the paper is the lung cancer is one of the most common cancer. So if I think the lung cancer is lung cancer is one of the most common cancer. Actually, it kills more the people among in our lifestyles, even in both men and women. So not only in men, we actually we think that only the men can be affected by lung cancer since they are smoking. So not only that, even in the women we get lung cancer because of avoiding chemotherapy, so diet maintenance. So just standing beside of the smoking person, even that smoke can also affect the lungs. Even that is also one of the one of the reason for our lung cancer. So I thought to choose why can't we predict the lung cancer using this because I love data mining. So I just used it on prediction of lung cancer. And one of the algorithm I have used is support vector machines and also random forest. So as I said, how lung cancer affects. So lung cancer is it's not one. It's mainly affected in adults between the age of 55 and around 60-65. Actually, it frequently develops over a period of years, not only in the starting stage. Even we can able to predict in the starting stage. So for that prediction, I have introduced this paper. So as a result, the software for forecasting illness like lung cancer is required. So this is the requirement, the efficiency of machine learning algorithms for forecasting the lung cancer. So as I said in this research, I have used the random forest, which is popularly known as ORF, and the support vector machine algorithms, the classification of algorithms. So as I said, the methods and methods, and these are the two methods I have used. So first, actually, I have done my data set description in using a machine learning repository for this research. So in the random forest, so when we used random forest, it is a supervised learning method. It is used to classify and diagnose the data. So this algorithm is applied for solving the categorization. So இப்போ ஒரு data எடுத்தோம்னா அதை அப்படியே categorize பண்றதுக்காக, so I have used this random forest. So as a result, as we know, the random forest algorithm in data mining is sub classification of 3 nodes. So as a result, so I got some output over there. So சில data சோட செட் மட்டும், so எனக்கு அதுல வந்து output கிடைச்சது. So அதுல இருந்து வந்த data வந்து, so as a result of data, so I have just applied to that to support vector machine algorithm. So even when I use support vector machine algorithm, I have seen the accuracy when compared to the random forest algorithm. I can see the accuracy is somewhat good in support vector machine algorithm. So, and this is also is one of the supervised learning models. So SVM is one of the most popular classification technique, which is a great way of processing nonlinear data. So this is also one of the essential tool. So SVM use பண்ணும்போது, so அந்த line prediction, so like a border line, so நமக்கு கீழ, I mean அந்த line கீழ வந்த data எல்லாமே பாத்தீங்கன்னா it's not predictable. So when I go the prediction data, when I compare to random forest, so SVM gave me the best one. So I have seen many of the research have used many of the algorithms like random forest algorithm and support vector machine algorithm. So I had an idea to why we can't able to introduce one of the new method in introducing in prediction of lung cancer. So we have used this optimized ORF algorithm. So optimized ORF algorithm, which is nothing but the comparison of both the random forest and the support vector machine. So when I used optimized RF algorithm, it includes both features of the SVM and RF. Since SVM is found that is one of the good classificator, the output is classified in the SVM when compared to the random forest. So I suggested optimized RF algorithm, which we have introduced, was one of the best method. So when compared to both RF and SVM, and these are the algorithms. So these are the 3 algorithms. Finally, we got optimized RF algorithm. The 2 major algorithms we have proposed here was random forest and SVM, and the final algorithm which we were introduced was optimized RF algorithm. And these were the accuracy, precision, and recalls. So accuracy, precision, and recalls, which I were introduced in the graph methods. So these are the values which I have found. When accuracy in the random forest, I got only 82. When SVM, when it's 85, and when compared to optimized RF algorithm, it was 87. So I found for precision also. The precision, the percentage of random forest is 70, and SVM is 75, and for recall it's 77 again. So and for random forest again it was 75, and SVM percentage was 87, and optimized was 88. So when I compared all this, I was we were in the best application of the optimized RF algorithm. Since we have compared our random forest and SVM, we gave the best prediction in the SVM. So why can't we introduce in the new algorithm? So we proposed a new algorithm named optimized RF algorithm. The optimized RF algorithm is a combination of both or random forest and SVM, and and which has both the features of RF and SVM. And the last prediction which we got was optimized RF algorithm, which was one of the new method we have introduced. And so the efficiency of two classification algorithms such as I said before, SVM and random forest for predicting the lung cancer is explored in this research of my lung cancer research, and the XVM is shown to be most useful in predicting lung cancer. So that is also one of the good classifier, as we all know, and even the random forest is that also one of the best method. So since as we SVM is proved to be good classifier, so we have compared finally and proposed an optimized RF algorithm, which is more effective than to existing algorithms when we applied individually. And this is my research map. So lung cancer. So I have just taken the prediction of lung cancer by using the RF and the SVM. So and finally comparing both of them, we have introduced we have proposed a new algorithm which has both of the features of SVM and RF, and we have named as optimized RF algorithm. And thank you for this wonderful opportunity. So since it was my first presentations, and really thank you for making me to attend and present me in this conference. And thank you, ma'am. Thank you so much.
Hello, Kavita.
Ma'am, yes, ma'am. It's me.
Okay. Good presentation. I have few questions.
Yes, ma'am.
Your work is about prediction of lung cancer, right?
Yes, ma'am.
Okay. What is your input?
Data set, ma'am.
Yes, I'm asking about the data set.
Yes, ma'am. It was retrieved from museum machine learning repository.
Okay. What is the form of your input? Whether it is data or it is image?
Data, ma'am.
Data. Why you compare your SVM algorithm with random forest? Why do you choose random forest for comparative analysis?
So I have seen lot of papers, ma'am. They have also used a random forest. So I got interest in using why we can't also apply this one. So I just took, and when compared to others also, so I had an idea of proposing one new algorithm, ma'am. So since I'm a fresher, so I got interest in the research. So it made me to choose that, ma'am.
Okay. Okay,
Thank
ma'am.
you, ma'am. Thank you, ma'am.
Hi, Kavi. I have a doubt.
Yeah, ma'am. Sure, ma'am.
Like if you're saying data is the data set, right? What are all the what is the structure of that data? Could have been better if you could have included the screenshot of the data set, was what I felt.
So, hello?
Am I audible?
Ma'am, your voice is low, ma'am.
Am I audible now?
Yeah, ma'am.
Okay. What I felt was it could have been better if you could have attached the screenshot of the data set.
Yes, ma'am.
What is the structure of that data actually? Can you name me few columns from the data?
Actually, I didn't present in the presentation the screenshot of the attributes, ma'am. So I missed it.
Okay, yeah, that's why I'm asking you.
Yeah, yes, ma'am.
Can you tell me a few attributes of the data? I mean the input data set.
Once.
No, you can just name me. You don't have to show. It's fine. You
Hello?
can just if you can just say that.
Hello, ma'am.
Hello.
Yes, ma'am.
It's fine if you just name me a few attributes. It's fine. You don't have to show that.
Just a minute, ma'am. 1 second.
Okay.
Kavita, you tell us what are the attributes.
Yeah, that's it. It's fine.
No need to show it.
Shall we present, ma'am?
What are the attributes you have taken?
Actually,
Have you implemented?
Ma'am, actually, I have kept a screenshot, ma'am. So, but I didn't present in that my PPT.
No, it's okay. You don't have to show us the screenshot. You can say us verbally. You can just say us few attributes that are in the data set.
Hello, ma'am.
Yeah, you are audible. Yeah.
Can I just say the attribute or show, ma'am?
No, you can just say.
Actually, in using a machine learning repository, so all
Okay.
the attributes were 0 to 3, ma'am.
No, I'm asking the name of the attributes. I'm not asking the data.
Actually, the name. Actually, I have not seen the name that, ma'am. So I have seen the values.
Okay, fine.
These
Thanks.
values corresponds to some attribute, right?
Yes.
So we are asking about the
So,
attribute name.
so attribute that I remembered that the attribute one they have named as a class label and the values they were kept was 0 to 3.
Okay. What does that correspond to? Like class label in the sense?
0 or it may be 1 to 3.
Have you really implemented?
Hello.
Have you really implemented?
Yes, ma'am. We were there.
Okay, ma'am.
Okay, thanks. Thank you.
Thank you, ma'am.
Thank you, ma'am. Now I call upon the paper ID 245 respiration rate estimation from photoplethysmography signals using deep learning. NGFL, Dr. R. Rajeshwari.
Yes, ma'am.
Yes, ma'am, you are audible. Share your screen, ma'am.
Yes, ma'am. Ma'am, is my screen visible?
Yes, ma'am. Visible.
Yes,
Start.
ma'am. So my presentation is based on respiration rate estimation from photoplethysmography signals using deep learning. So it's presented by myself, NG Nefel, and Dr. R. Rajeshwari, ma'am. So the agenda of this presentation is introduction, literature review, objectives, proposed methodology, experimental results, conclusion, and references. So respiration rate, it's a number of breaths per minute. It's one of the first vital signs to fluctuate when the body suffers from serious illness. It's a good predictor of cardiac arrest. In clinical practice, current clinical practice, respiration rate is measured by counting chest wall expansions. But this is highly prone to inaccuracy and inconvenience. And there are other technologies like inductance plethysmography, capnograph, bioimpedance-based sensors, electrocardiographs, photoplethysmography technologies. Among all these, photoplethysmography technology have gained popularity in the market due to the following advantages, such as it is non-invasive and is convenient and user-friendly to measure, inexpensive and portable. It is integrated with our day-to-day life appliances like smartphone, smart watches, finger probe, arm band. In this work, I have chosen photoplethysmography technique to estimate to measure respiration rate. This photoplethysmography is a non-invasive technique for detecting blood volume changes during a cardiac cycle at selected body locations. So the measurement, how it is measured means skin surface, usually fingertip, is illuminated with using light-emitting diode, and the observed or reflected light is measured using photodetector. So respiration, this PPG. So from this we get the photoplethysmography signals. These photoplethysmography signals, the respiration rate modulates the photoplethysmography waveform. So these modulated respiratory variation signals are extracted from PPG signals, and from those the respiration rate is measured. There are ample research works being carried out in the computation of respiration rate. They are based on handcrafted rules and empirical formulas, and these technologies also produced large this respiration rate inaccuracies when dealing with sickness with artifacts. So in this work, I have proposed convolution neural network to estimate respiration rate from photoplethysmography signals, and I have also analyzed the performances of my estimation model. So the literature review here, the classical method, the PPG waveform, from the PPG waveform, respiration-induced variation signals are extracted, and from signals, respiration rate is calculated. There are so many techniques used to derive this respiratory-induced variation signals. Like in Carlin in 2013, he has proposed merge incremental segmentation algorithm and fast Fourier transform to extract respiratory-induced variation signals from PPG waveform. And in other paper, filtering technique is used to extract respiration signal. And in other paper, time frequency transform is used to extract respiration signals. But all these are on handcrafted rules and some empirical formulas, and also they produced inaccuracies when dealing artifacts. It's nice. So here there are also some techniques, machine learning techniques proposed by some others for the estimation of respiration rate from photoplethysmography signals. Johansson in 2003 has proposed neural network. Here also we have taken some handcrafted parameters like 5 different respiratory synchronous components of the PPG signals you have extracted and given as input to neural network, and has produced the error rate of 9.5% to 9.6% of the breath. In Brian in 2020, he has proposed convolutional neural network to estimate respiration rate from raw PPG signal and has produced promising results. So my objective is to increase the accuracy of this respiration rate estimation, and also by using machine learning rules. So in contrast to taking the depending upon the handcrafted rules, here we have just given the raw PPG signal to the deep learning regression model for the estimation of respiration rate, and then evaluate my method using measured vital signs to standard medical devices. Evaluate and test my method using the medical devices. So here are the proposed methodologies. I have used the data from Physionet's Mimic2 database, that is BitMC dataset. I have collected this BitMC dataset. It consists of 53 recordings of PPG signals. Each PPG signal is recorded of 8 minutes duration at a sampling rate of 125 Hz. And it has other reference ground truth values like reference respiration rate, heart rate, and blood oxygen saturation, all those things. So the data set is collected from this Mimic2 database, and from this I have chosen PPG signal and reference respiration rate. This PPG signal is then partitioned. Because it is of 8-minute duration, I am partitioned into in such a way each partition contains signal of one second duration, so that I get more number of samples for training purposes. And each PPG signal I am converting to another representation. That is time frequency representation. The spectrogram. There are many different time frequency representation. I have taken here spectrogram. Conventional method is a spectrogram, and so the converted spectrogram and the reference RR is given as input to the convolution neural network. And I have predicted the model. I have developed the convolution neural network model to predict the respiration rate. So the compared to the existing work in BioND, he has just given the raw PPG signal to the convolution neural network. In this work, I have rather than giving the raw PPG signal to the convolution neural network, I have converted to time frequency spectrogram, and that spectrogram I am given for training purposes. That is the main contribution here. And here, since this time frequency spectrogram has some special properties, the patterns, it enhances the patterns that may not be even visible in the original raw signal. So this may improve the results. So I have converted this into time frequency spectrogram and given as an input to the convolution neural network. So this is my work as a convolution neural network. This I have here. The architecture is there are two series of convolution layer. The first convolution layer was constructed with 4 filters. Each filter is of size 2 by 2 and with the straight length 1. And this convolution neural network is applied with batch normalization layer, which is followed by ReLU operation. And next comes the pooling layer. Pooling layer consists of a filter with the size 2 by 2. And then followed by that, the second series of convolution layer is designed, which is same as the first layer. It is followed by batch normalization layer and ReLU layer. Finally, so this two, pooling layer and the convolution layer, act as a feature extraction, used for feature extraction. And then comes the fully connected layer, which is the regression layer, which is the output size is 1, which predicts the respiration rate. So this the fully connected layer acts as the predictor. It is a predictor. So, and the training is performed for 30 epochs with 177 iterations per epoch. And the solver is adaptive moment estimation is used. So the results is the error histogram I have derived is x-axis the error and the y-axis the frequency of samples. So from this error histogram, it is observed that 82% of the samples are produced error rate 3 and less than 3. And the bland argument plot I have constructed. Here the limits of agreement is 6 beats per minute. So which is acceptable in clinical practice according to some from the literature survey. I have found that it's acceptable. It's the 6 beats per minute is acceptable. And here I have also, not even here with 1 second, I have also developed separate models by varying the length of the signals with 30-second signal, 10-second signal, 5-second signal, and also 1 second signal. But the 1 second signal has given good results because it contains maybe more number of samples. More number of samples were there when divided into 1 second partitions has given good results. When compared to the prior work, Bayan's work, the MAE is I have got low MAE, but standard deviation is comparatively high. So I have to improve my work. In comparison, in the previous work, they have included 2 databases, BitMC and CapnoBase. So in the future work, I could include the CapnoBase database and I can test my results. So the conclusion is, so I have estimated the convolution neural network to estimate respiration rate from photoplethysmography signals. Here I have converted the raw signal into the time frequency representation and given as input to the convolution neural network model. I have produced the MAE, which is low 2.25 when compared to the existing work, and the standard deviation of 1.90. And my work has to be, I have to improve my work by increasing the training data set. So these are my references. Okay. Thank you, ma'am. Thank you for giving me the opportunity.
Thanks. Now, I have only one question for you.
Yes, ma'am.
Can you go? Okay, the slide is enough. You have used mean absolute error for error metric, right?
Yes, ma'am.
Why did you choose mean absolute error?
Ma'am, in all the papers,
Mm-hmm.
the metric is this metric they have used, ma'am. Mean absolute error metric and standard deviation they have used in all the papers in measuring vital signs. They have used this metric: mean absolute error, standard deviation.
Okay, so you just followed that. Okay.
Yes, sir. Yes,
So
ma'am.
no other particular specific
No
reason for going
particular,
for any.
comparing with
Because,
the other. Yes.
okay, because okay. Did you try RMSE? Uh,
RM, root mean square error.
yes, root mean square error.
Root mean square error. Yes, ma'am, I have taken, but
Okay.
here I have not
You proposed
mentioned.
only this. Okay.
Yes, ma'am.
Okay. Okay. Thank you.
Thank you, ma'am.
Hello,
Yes, ma'am.
I have one question.
Yes, ma'am.
What is the size of your data set?
Ma'am, my Bitamsi data set consists of 53 recordings. Each record is taken from a patient. That is, one record contains data signal recorded for 8 minutes duration. PPG signal recorded for 8 minutes duration. And its sampling frequency is 125 hertz. So from a single person, I get so many values. For 1 second, 125 values of respiration rate I get. And the PPG
Have you
signal.
collected the clinical data set?
Ma'am, only benchmark data set I have collected, but in my work, but in this work I have not proposed, but I have in another work I have collected data from smartphone. Using smartphone, I have collected this. I have captured PPG signal from 30 volunteers and have done this. The same work I have implemented that, but in this presentation I have not proposed that.
Okay. Okay, ma. Thank you.
Yes, ma'am. Thank you, ma'am.
Thank you, ma'am. So participant kindly, thank you. So
Thank you, ma'am.
stop your screen after presenting. So now we call upon the paper ID 73, diabetic prediction using hybrid ensembling of different machine learning classifiers. The authors are Ms. R. Pramita, Dr. S. Chidambaram. Participant Kavi Bharati ma'am, will you stop presenting your screen, ma'am? Kavi Bharati ma'am. Stop your.
Ma'am, is my screen visible?
Yes, yes.
Yes.
Yeah.
Yes. Visible.
Good morning, all. I'm Primita. I'm going to present a project titled as Diabetic Prediction using Hybrid Machine Learning Approach. And my guide is Dr. S. Chidambaram. We are from National Engineering College, Kovilpatti. Introduction. Diabetic is a common chronic deadliest growing disease in the world. It is not only a disease but also a creator of different kind of disease like heart disease, stroke, blindness, kidney disease, etc. Diabetics can be divided into several different types. Like it has two types, type 1 and type 2. Type 1 is depends on the genetic disorder, and type 2 comes if we are not maintaining our diet. The nature of heart disease is complex, and hence the disease must be handled carefully. Nowadays, the perspective of medicine science and data mining are used for discovering various shots for this metabolic syndromes. By using our data mining algorithms, we can predict and we can reduce the illness of diabetics. The objectives To implement the machine learning algorithms of hybrid random forest with logistic regression and decision tree, naive Bayes, and support vector machine to predict disorder of diabetic of pregnancy, and to perform a comparative analysis of these algorithms to achieve high accuracy compared with the normal algorithms. In this, I am comparing the three algorithms: decision tree, naive Bayes, and support vector machine. Among the three, which one is best? I'm taking with that. I'm comparing the hybrid of random forest and logistic regression. In this, mainly I'm the main objective of this is to get higher accuracy. I'm comparing these both algorithms. Abstract. The diabetic disorder cannot be cured, but early detection and timely treatment can stop the progression. The machine learning technique and algorithms like logistic regression, decision tree, naive Bayes, random forest, and support vector machines are used to predict diabetics in my project. Hybrid ensemble machine learning technique is proposed by combining random forest and logistic regression. In this, the extracted features are inserted into the models which I choose, and it gets trained by the machine learning algorithm. After training, we can predict diabetes by feeding the test data into the best model, which I choose to do this one. Literature survey. In this, I go through in some papers to do my project. These are the literature surveys which I refer. Problem statement. Diabetic can cause problems during pregnancy for women and their developing babies. It also causes illness to the babies. Poor control of diabetics during pregnancy increases the chance for birth defects and other problems for pregnancy. It can also cause serious complications for the woman. It causes all humans, but mainly it causes pregnancy women, and also it causes illness to the child while it's growing during pregnancy. This disorder cannot be cured, but early prediction and timely treatment can stop the progression, and it also reduce the severity of risk um, if we predict it earlier. Means proposed work. At first, the diabetic datasets are applied as input dataset by using the pandas library. Then pre-processing the data by removing the null values, and we are doing a future selection by selecting input futures for feeding it to the algorithms like SPM, naive Bayes, decision tree, and also the hybrid algorithm of logistic regression and random forest. A hybrid ensembling machine learning technique. By combining the random forest and logistic regression, the extracted features are inserted into the machine learning models, and by that models, the machine gets trained. After training, we predict diabetics by feeding the data into the best model. This is the flow diagram of my work. First, we are giving a patient dataset for data pre-processing. In that, it removes the null values and duplicate values, and then I'm giving that to the algorithms like logistic regression, random forest. Then I'm hybriding these two algorithms, and also I'm giving that to decision tree, SBM, and naive Bayes. I'm getting a result which one is better, giving better accuracy among these three, and also I'm comparing the result of these three algorithms with the hybrid of logistic regression and random forest algorithm. And after that, I'm comparing the two results, and finally I'm getting the results of my work. Support vector machine. It is a supervised machine learning model. Um, it uses classification algorithm for two-group classification problem. Why I am choosing support vector machine is it gives better accuracy in result, and also it is a fast prediction when compared to other algorithm. This is support vector machine diagram. Naive Bayes. Why I am choosing naive Bayes is it is a easy and fast to predict the class of test data set, and it is a multi-class prediction used to predict different class based on various attributes. Next, decision tree. Decision tree is used to solve both classification and regression problems. It provides effective method of decision making, and also it used to analyze the possible consequences of decisions. So I used these three algorithms, and I'm hybriding the random forest with the logistic regression. Logistic regression is the most popular machine learning algorithm under a supervised machine learning technique. It uses the dependent variable using a given set of independent variable. It logistic regression also we can use for both regression and classification problem. Uh, and random, why I'm choosing random forest is it reduces the overfitting problem in decision tree, and also it reduces the variance and therefore improves the accuracy. So I'm choosing these two for hybriding. In this project I'm using this 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 is a data set. These are the data set attributes of my work. Software and hardware specification. In this I used a PC with OS and 4 GB RAM. And software tools, I used Python and Python software packages. First, in that three algorithms, I got a better accuracy in decision tree. And I only compared these three algorithms. Now I started to work on this hybrid algorithm. After doing that, I compare this both and I will conclude my work. Um, Prediction is a challenging and very important in the medical field. The mortality rate can be drastically controlled if the disease is detected at the early stage, and preventing measures are adopted as soon as possible. The performance matrices like accuracy rate, precision, recall, F measure, and error value have been taken for decision tree, SVM, and naive Bayes in this work. Among that three work, decision tree algorithm has given higher accuracy. In my future work, I'm going to do the hybrid of logistic regression and random forest algorithms. These are the reference paper which I referred to do my work. That's it. Thank you, ma'am. Thank you all for giving.
I have few questions.
Yes, ma'am.
So you said about your work is compared with normal algorithms. Go to the first slide. First or second slide. Previous.
This one, ma'am.
Next.
This one.
Here you achieve high accuracy, and that will be compared with the normal algorithms.
Yes,
Can you
ma'am.
list me what are the normal algorithms?
Normal algorithms like that three algorithms only, ma'am. SVM, decision tree, and random forest, ma'am. I'm comparing
Why
hybrid
it
of
is called as normal algorithms?
not a normal algorithm. Single algorithm I mentioned is normal, ma'am. Sorry.
Okay.
I
Then,
compared hybrid with this single algorithms, ma'am. That only I mentioned as normal. Sorry, ma'am.
okay. Then you proposed a hybrid algorithm,
Yes,
logistic
ma'am.
regression and random forest.
Random forest, yes, ma'am.
How will you do the hybrid? Whether it is sequential or it is parallel operation. So when you say hybrid, you have to clearly give the process of hybrid.
Okay, ma'am.
Hmm.
I just last week only I started to do this hybrid process, ma'am. Just now I'm studying about that hybrid process. I have an idea, but I still didn't get clear
Okay,
cut idea, ma'am.
you say me? What do you mean by hybrid? What do you mean by
Uh,
hybrid?
using any two or three, two or
Okay.
more algorithms as a One and creating one new one from the two algorithms, ma'am.
Okay. Not creating, getting the output from the hybrid.
Yes, ma'am. That.
Okay. So if you are talking about the hybrid, then you have to explain about the process of hybrid.
Okay, ma'am.
Whether you are going to give the input of the first algorithm, output of the first algorithm to the input of the second algorithm, or
Yes.
are you doing any different kind of hybrid? So you need to
Okay.
explain.
Okay, ma'am.
Okay.
Okay.
Thank you.
Hi, Pramita. I think you can go to the slide of the process flow where you have explained that model. Can you go to that slide?
Yes, ma'am.
So basically, this is what you are explaining as hybrid model. Am I right? So
Yes,
you are
ma'am.
getting the data set and you are pre-processing it, and then you are giving the same pre-processed data to different algorithms
Yes, ma'am.
at first as a single to a single algorithm, which is logistic regression and then random forest.
Yes, ma'am.
After that,
After that,
you have written something as hybrid. So
I'm hybriding these two algorithms,
mhm.
logistic regression and random forest.
Okay,
And then,
to ma'am's question, I think you have to explain in detail about this slide. Okay, this was
okay,
what she was expecting, is what I think. And my question would be, why did you choose SVM, naive Bayes, and decision tree separately here? Any specificity for using this particular algorithms? Because for using logistic regression and random forest, you have told some reason.
yes, ma'am. Why I choose logistic regression? Na, we,
Yeah, that you have explained in the presentation. You had points for that. But why did you choose decision tree, SVM, and naive Bayes?
in already some I researched some paper. In that paper,
Mhm.
they used some algorithms, ma'am. From that, I chose these algorithms because these three are gave high accuracy, and they are used for classification and regression problems. So I choose these three, ma'am.
Okay, thank you, Pranita. That's it.
Okay, thank you, ma'am.
Now I call upon the paper ID 82 cardiovascular disease prediction using machine learning approach. The authors are K.S. Jayashree, Aishwarya, Rahul, Dr. S. Chidam.
Good morning, ma'am. Whether I am audible?
Yes, you are audible.
Okay. Good morning, ma'am. Myself, Jayashree. Today we are going to give a presentation on the topic heart disease prediction using machine learning algorithms. And my team consists of two members, other two members. They are Rahul and Aishwarya. And our team was guided by Dr. S. Chidambaram from National Engineering College. Introduction. Our research is about predicting a solution, accurate method for finding a cardiovascular diseases. Cardiovascular diseases, number one cause of death. Compared to other diseases, and estimation of 17.3 million people died due to cardiovascular disease in 2020, which is 30 percentages of global death. Over 80 percentage of cardiovascular disease death takes place in low and middle income countries, which is equally among men and women. And research found that by 2030, about 23.6 million people will die due to cardiovascular disease, which provide a means and think to make us to took this project problem statement. Heart disease are critical health issues. Numerous people are affected by this. The problem is that researchers try to find an efficient technique for detection of heart disease as a part of past diagnosis techniques, which involves much difficulty in identification due to several reasons, such as low accuracy and more processing time. The diagnosis and treatment is extremely difficult without a proper technique. Abstract. An accurate and efficient approach for detection and prediction of heart disease is a primary objective, and proposed methodology is developed based on classification algorithms such as KNN, decision tree, random forest, and support vector machine. Uh, and these are all the base models, and again by using an meta model, which is a logistic regression, using that will combine the results obtained from these base models, and the total approach is called ensemble stacking, and our proposed method will provide a higher accuracy and a unique feature of predictive analysis about the risk of heart abnormalities. And the main goal of our technique is providing a quality health care for elderly and high risk heart patients. Workflow diagram. At first, we have imported the data set from UCI repository, which is Kaggle, and it consists of 4,122 data set records, and it has about 13 input attributes and one output attribute. And pre-processing, which is nothing but processing of raw data. Using that, we are cleaning and formatting the data, which is removing the error data and encoding the data. And future selection. Here we are filtering the appropriate attributes and which is relevant to our machine learning approach, and removing the other attributes, and training and testing our data set. We have used about 70% of our data set for training the algorithm, and for testing we have used 30% of data. At first, we'll apply the data to the base models, which is SVM, decision tree, random forest, and that results acquired from those algorithms will be given to the meta model, which is a linear regression, and from that we'll acquire the output. Further will be continued by Aishwarya.
So good afternoon, and now I'm going to explain about the methodology which is used in our project. And here we have used classification algorithms to the data set to find the best performer algorithm by comparing the accuracy and other statistical variables. Then we have applied KNN, random forest, decision tree, and SVM. So these algorithms were compared based on their performance evaluation matrix, such as true positive, true negative, like that. And then we have used stacking, which is an ensemble method, a machine learning algorithm, which helps us to learn about how to combine the predictions from a multiple world performing machine learning algorithms as we have applied. And then a confusion matrix is obtained to calculate the sensitivity, specificity, and accuracy of the result for each and every algorithm. So next. So first we have taken KNN. As I have said, it consists of three parts. And first we have to calculate the equilibrium distance, and then we have to get the K nearest neighbors. That is, a value of K should be obtained. And then in step 3 we have to make predictions. So these steps will provide the fundamental implementation by applying the KNN algorithm for classification and regression predictive model. And then here, when a prediction is required, the K most similar records to a new record from the training dataset are then located, and then from these neighbors a summarized prediction is made. And then next we have used this decision tree. As we all know, the decision tree is nothing but a graphical representation of all possible solution to a decision. So here we have implemented by using 5 steps, and just it begins with a normal set S as the root node, and then on each iteration, it iterates through very unused attribute of the set S, and it calculates the entropy and information gain. And then in step 3, it selects the attribute which has the smallest entropy or largest information gain. And in the step 4, the set S is then split by selected attribute to produce a subset of the data. And then in step 5, the algorithm continues to return on each subset, considering only never selected before. So this will be repeated again and again. And then next slide. So next one is random forest. It adds some additional randomness to the model while growing the trees, and then it searches for the best feature among a random subset of features, and it provides a wide diversity of result, which provides in a better model. And then in random forest, only random subset of features is one alone taken to the consideration of algorithm for splitting into a node. And then random forest has nearly same hyperparameters as a decision tree or a bagging classifier. Next. So next is support vector machine, and then it is a set of super learning methods, as we all know. And then it is a quick and dependable classification algorithm which performs well with a vast amount of knowledge. And then it analyzes the defect cells based on million of images to predict feature driving routes. And then the specific types of SVM we can that we have used for particular machine learning problems like the support vector regression, which is an extension of support vector classification. Next. So these are the experimental results, and here bar graph have been shown. And then here we have compared data attributes such as sex and then count. Here female 0 is equal to female and 1 is equal to male. Here we have obtained the graph by comparing these two attributes. And then next. So this is scatter plot of our project, and then here we have compared age and the minimum heart rate. Maximum heart rate, and the person who are all affected by disease will be indicated by green color, and not affected by heart disease will be indicated in black color. So this will be continued by Rahul. Thank you.
Good afternoon, ma'am. And this is the output we got it from the, as mentioned earlier, we come up with an ensemble model. This is the output we got from the ensembling model, and from that we found that the accuracy of that model is 0.93. The ensembling model comprise of the output of all the output got from the different algorithms we have used in this model. By combining all those results, we come up with and find that the accuracy of the model is 0.93%. Next. Components required, the hardware tools which we are used to done this project is and PC with an OS the minimum of 2 GB RAM. Software tools what are the software we use to do this project is Python, IDE 3.7.6, PyCharm, and software packages we used is NumPy, Matplotlib, Skitlan, Seaborn, and sklan. These are the software tools and hardware tools we used in this project. And the next is conclusion. We all know that heart disease is one of the major disease in every human being. So we come up with an idea to predict the heart disease with the accurate manner with the less number of features and tests. The KNN support vector machine, decision tree, and random forest. These are the algorithms we have used. The information which we given to the data set is pre-processed and being utilized in this model, and then this output got from all this algorithm were ensambled to lower the rate of misclassification and increase the classification performance. By the process of stacking CV, the and classifier considerably improves learning accuracy. According to the findings, discovered to it is discovered that it is well performed to this data set, and it has also value addition to the patient care. Next. Reference, these are all the papers we have refer to do these projects. Next. Thank you, ma'am. Thank you for giving opportunity for us to present the paper.
Thank you. The data set is sourced from Kaggle. Am I right?
Yes, ma'am.
Can you tell me what are all the pre-processing techniques that you have used for this?
We have used lasso, ma'am. Least absolute selection shrinkage operator.
Okay, I mean you have collected the data. After that, what were all the steps involved in data pre-processing? Is what I'm asking.
Yes, ma'am. We have applied the process called lasso.
Okay.
Using that, we have pre-processed, removed the error data and categorical values. We have encoded that using the lasso technique, ma'am.
Okay, fine.
Why do you choose ensemble methods?
Already several research have done comparing individual algorithms and acquired output. We thought of combining several algorithms and come up with the best accuracy results.
Okay, thank you.
Thank you.
Thank you, ma'am. So now I call upon paper ID 114, Predictive and Comparative Analysis for Diabetics using Machine Learning Algorithms. The authors are J. Ponneshwari, D. Saranya, Premchand, Dr. S. Chidam.
Whether my screen is visible?
Yes.
So, good afternoon, one and all present here. I am Ponneshwari, final year IT department, UG student of National Engineering College. Here is our project title, that is Predictive Analysis of Diabetes using Machine Learning Algorithm. And this is all our project teammates and guide. And introduction. As we all know, the diabetes is the most common chronic and deadliest growing disease in the world. And it is not only the disease, but also the creating of a various kind of disease like heart attack, stroke, blindness, and kidney disease also. And generally, the diabetes mellitus can be divided into the two types, like a type 1 and type 2 diabetes. And the people's also affected at the age of below or a middle or above middle age. So that the nature of the heart disease is complex and hence the disease must be handled carefully. Not doing so much may affect the heart or cause premature death. The perspective of the medicine, science, and the data mining are used for discovering the various sort of metabolic symptoms. So coming to our problem statement is that diabetes is a chronic and a growing common disease which can increase the glucose level in the blood due to the lack of insulin in our body. If the diabetes remain untreated or unidentified, it leads to the many complicated issues to our health to the majority of the people. So this disorder cannot be cured completely, but while we predict early and taken the timely treatment can stop the progression and the severity risk of the disease. So this is what our problem statement. And the next thing will be continue my teammate.
Hello everybody, I'm Premchand. My project objective was to implement machine learning algorithm of a hybrid neural network with logistic regression and a decision tree, naive Bayes, and a support vector machine. These are the algorithm to predicting disorder of the diabetes and perform the comparative analysis for getting the high accuracy, which is best. Now, next slide. Abstract. The diabetic disorder cannot be cured, but the earlier detection and the timely treatment can stop the progression and control the severity risk factor of the disease. The machine learning techniques and algorithm like logistic regression, decision tree, naive Bayes, neural network, and support vector machine to predict diabetes. And the hybrid ensemble machine learning technique is proposed by combining neural network and the logistic regression. The extracted feature are inserted into the model and it gets trained by machine learning. After training, we can predict the diabetes by feeding test data into the best model. Further slide will continue by Sam.
And this is all some of the literature survey papers we have been collecting for our project work. And this is our proposed.
Good morning, I am Saranya. The proposed work of my project is first the diabetes datasets are applied into the pandas library, then pre-process the data for removing the null values, then make the feature selection by selecting input features for feeding the support vector machine, naive Bayes decision tree, and the hybrid algorithm of artificial neural network with logistic regression. Then after the training, we predict the diabetes by feeding the test data into the best model. The next slide. The next one is flow diagram of our project. First, we collected the diabetes disease dataset from Corgel website. This data consists over the 6,000 patient data, has features such as number of pregnancies, glucose level, blood pressure level, skin thickness, body mass index, diabetes pedigree function, age and outcome. Then we pre-process the data by dropping the null value. Then we make feature selection by selecting input features for feeding it into the support vector machine, naive Bayes decision tree, and a hybrid algorithm of artificial neural network with a logistic regression. A hybrid ensemble machine learning technique by combining the neural network and logistic regression by using the voting classifier. The extractor features are inserted into the machine learning models. The machine get trained. After training, we predict the diabetes by feeding the test data into the best model. Next slide. Next one is the methodology. We have using the methods of support vector machine, naive Bayes, and decision tree, and a hybrid algorithm of artificial neural network with a logistic regression. Next, continue by a teammate.
Yeah, this is all about the algorithm we have been used in our project, like SVM, naive Bayes decision tree, and the hybrid of ANN with LR. The reason we are combining with the ANN with LR is that ANN is the artificial neural network and LR is the logistic regression. So the reason we plan to combine with ANN with LR is that ANN is really helpful to provide the high accuracy prediction, and it's also, it can store the lot of informations of the entire network, and it will be really helpful for the parallel processing. And coming to logistic regression is for useful for the binary classification. As per our data set, we have been using like a prediction of diabetes like yes or no, that categorical value. So the binary classification will be the better chance to combine with ANN with LR. So that we have been chosen the ANN with a combination of LR. Then after that, this is what our data set. We have been collecting really around 6,000 data set from Google website and some data science website, and also some demographic data also. So this is also some of the attributes which is present in our data set, like pregnancies, women data, and glucose level, and blood pressure, skin thickness, insulin, BMI, and pedigree, diabetes pedigree function, which is nothing but the historical value, whether that women in their um, families before that somebody has affected from this diabetes or not, just like a historical value and their ages, and that outcome is nothing but what we get at last, like yes or no. And after that, this is all some of the components, tools, requirements we have been using our project to implement, like hardware tools, like normal Windows OS, and the software tools. We have been using the software package like NumPy and Matplotlib library and Skitletland and Keras, and Python IDE 3.7.6 version we have been using. And after that, this is what our the result we can we have get it at last, like a hybrid algorithm while combining with the ANN with LR, we have getting the highest accuracy among the three, like decision tree, SVM, and naive bias. And this is what the analysis taught, like this is what our analysis taught, and this is what exact accuracy value while combining with ANN with LR, we get 0.9.9, and the decision tree, that is 0.7.1, and SVM 0.7701, and naive bias 0.7597. And coming to our conclusion is that the performance matrices like the accurate rate, precision, recall, F measure, and the error values have been taken for the three algorithms like a decision tree, SVM, and the naive bias. But while we are combining the ANN with LR, like hybrid algorithm through the voting classifier, it will giving the highest accuracy among the three algorithms. So what we have does in the sense, ANN in the LR, we have taken that output, we have taken the input while training our data through ANN, and with that result, we have been, after that, while we are tracking the result, we just keep it at one side, and after that, the logistic regressions also, we have giving the train data as well the test data, and we have been combining both the results of ANN with LR with the voting classifier. Actually, the voting classifier is having a hard voter and soft voter, like which will giving the highest probability. With that class, it will giving the output. So for that basis, we have done this, and this is what are the reference we have been collecting to our project. And thank you for this wonderful opportunity to present.
Okay, ma. You have done the performance analysis. What are the parameters you have taken for the performance analysis?
Yes, ma'am. We have taken the precision, recall, F measure, like those parameters, ma'am. But mainly we have been comparing with accurate rate only.
Okay,
We
you have
have
shown only the accuracy graph, comparison of accuracy graph. What about the others, other parameters comparison?
yes, ma'am. We'll have, but we are not just paste it in a PPT, ma'am. Actually, we have a thought like we have comparing all those algorithms with accuracy only, so that we we are just forgot it to paste it. But we have implemented, ma'am.
Okay, 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 okay. So similarly, you have mentioned compare your algorithm results with the normal algorithm. Go to the second slide or third slide. The previous batch, they have mentioned comparison with the normal algorithm. Your team also mentioning the same.
Yes, ma'am. Previously, me and that team also in the same batch, so that we have been shared the same
I don't
PPT.
know what is normal algorithm. Do you find any abnormal algorithm?
No, ma'am.
Okay. Okay, thank you.
Okay.
Hi. So about the voting classifier, what is the voting parameter that you have set to?
Voting parameter. Actually, ma'am, we are just getting the output from ANN with LR, and we are just simply putting that two parameters inside with the voting classifier function.
Okay, no, you yourself mentioned, right? There are two voting parameters,
Oh, yes, ma'am.
so that's why I asked. Okay then.
Now I call upon the paper ID 301, depression analysis using visual and textual cues. Skip on Kartika. Share your screen. The authors are Pon Kartika, Doctor is Kavipriya, Doctor is Priyadarshini.
Good afternoon, ma'am. Am I audible?
Yes, Pon Kartika.
Okay, ma'am. Good afternoon, everyone. Myself, Pon Kartika, research scholar of CSE department at Mepkoshlank Engineering College. I'm here to present my project work entitled Depression Analysis Using Visual and Textual Cues. This is my agenda for today's session. First, let's see the problem statement. The depression has been the leading cause of the worldwide mental health disorder, affecting more than 300 million people, and is a key reason for suicide. The global pandemic has created a huge impact on the mental health, leading to 27.6% increase in major depressive disorder cases across the globe. So the development of the early prediction system can contribute greatly to the mental health industry for providing appropriate medications in early stage, which will reduce the emotional and financial burden associated with the disease. So we are here. So we are planning to propose a solution for depression analysis. Uh, Here are some of the related works of the recent presented by the recent. The first work is dedicated for depression diagnosis using facial
You
appearances.
please skip the literature survey. Move to the next one.
Okay. These are the objectives of our proposed work: to develop a multimodal depression system integrating video and textual features, to extract the text features revealing depressive content from the text dataset, to extract the low-level descriptors from video samples, then fusing both the text and visual features to predict the depressive symptoms. This is the objective. These are the objectives of our proposed system. First, I'm going to describe the data set that we have used to develop the system. The first data set is the extended distress analysis interview corpus dataset, which is an extension of DAIC wizard of OIZ dataset. The dataset is containing interview content of peoples, that is during the clinical interview with the depressive peoples. They are providing video samples, audio samples, and the conversation in the form of text. So that dataset we are going to use, and to train the text dataset we are using the sentiment analysis dataset. So we are training the model using the sentiment 140 dataset, and we are going to implement that model for the conversations captured during the interviews. This is the sentiment analysis dataset. The dataset contains 1.5 million user tweets, which are classified as depression positive and negative, that is depressive and non-depressive, labeled as 1 and 0. This is our proposed work. First, we are giving the textual input to the first phase. Obtaining the textual input, the system will pre-process the text data by removing the noises, errors present in the data, and it will clean the data to make the data suitable for model training. Then we are using encoding mechanism, universal sentence encoder, to encode the text into the numerical form. Then that numerical format of the data will be given as input to the stateful by LSTM. Then parallelly, the video input is given as input to the video data processing stage, where the sampling of videos is done to get the screenshots of the videos. Then that from those screenshots we are getting the low level descriptor extraction. Then that extracted features are given as input to the stateful by LSTM. Then combining both the attention vectors from the both by LSTM models is given as input to the stacked by LSTM. From that stacked by LSTM, the outcome will be the depression level based on the PHQ scores obtained during the interview session. First, for text feature extraction, the first step is the text pre-processing. Next step is the universal sentence encoder. What is universal sentence encoder is it will encode the text into high dimensional vectors used for text classification, semantic similarity, and other NLP tasks. The pre-trained model is available in the TensorFlow Hub. Then the stateful BiLSTM model is used to train the model for a regression prediction. The model contains a 200 number of hidden units with batch size of 400. The activation function that we have used is rectified linear units. Then for video, the sampling is done at 10 Hz to get the coverage of all the possible features from the video, like pose, gaze, and facial action units. From the extracted features, the length of the features are 6, 8, and 35 respectively, and the time steps we have using is 15,000 time steps. The stateful LSTM for a video model contains of 9,000 time steps, and face action units number of features equal to 35, and the batch size with 1, that is it is set to 1 to leverage the state propagation during training process in stateful LSTM. The hidden cells is 200 and time step batch is 1. This is the fusion layer. The fusion layer is created to using the attention vector output from both the text processing and video processing. Then those outputs are combined through a stacked BiLSTM and an attention layer. The output of the attention are concatenated and passed through the attention, followed by feed forward layer, and a regression loss is propagated. Once the model is trained, we can use the model for any real-time video data associated with the text input. The system will predict whether the person is depressed or not depressed. This is the implementation screenshots. The first screen represents the home screen where you can where the user can log in using the mail ID. Then the third screen represents the provision for uploading the video data. Once the user has uploaded the video, then the system will analyze the video data associated with the text. Then it will find whether the user is depressed or not depressed. The performance comparison is done for a video dataset separately and a text dataset separately. First, this is the screen for a video dataset comparison. So mean square error is used to compare the video analysis with the baseline models and the two recently proposed model. Among those models, our model has less error rate when compared to the other models, so it is performing better. And for text, we are using 3 parameters: precision, recall, and F1 measure. For all those models, we are comparing it with Naive-Bayesian logistic regression, TDIF plus SVM. The proposed model is performing better when compared to the other models for all the metrics. So we can claim that our system will predict the depression more precisely when compared to other models. This is a summary. We have developed an NLP and deep learning approach for the text and video processing and depression classification. And we have used 2 different data types, sentiment 140 and EDISC dataset for our system designing. So these are some of the references, and thank you, ma'am.
Hi, first of all, appreciate you for taking this topic.
Thank you,
So
ma'am.
I think you stopped the screen. Can you show me the workflow slide?
Wait.
Yeah.
Wait a minute, ma'am.
Yeah, sure.
Yes, ma'am.
Okay, so basically, is this a sequential flow or a parallel flow?
We can process it parallelly, ma'am.
Okay, so you are doing it parallelly and then combining.
Yes, ma'am.
to arrive at the final
Yes, ma'am.
predictable
The
value?
attention vector from both processing will be
Okay.
combined at the final stage. Then the vectors are given as input to the stacked by LSTM. It
Okay.
will predict the depression level, ma'am.
Okay, so that's why even the error metrics you have shown as separate things for text and
Yes, yes, ma'am.
okay.
I have few questions.
Yes, ma'am.
What is pre-trained model?
Pre-trained model means the model is already trained, ma'am, using some based words with numerical values, ma'am. When we are giving the text means the words are present in our text will be converted to the numerical value based on the values in the model, ma'am.
Give some examples for pre-trained model.
Word embedding
No, I'm
models,
asking about the name of the model.
name of the models, ma'am. Universal sentence encoder is also a pre-trained model, ma'am.
Okay, what do you mean by activation function?
Activation function is sorry, ma'am. Activation function means it is to predict the output based on our input, ma'am. When to give when it is binary means it will predict to give us 1 or 0 to converge all the processing outputs into a single output, ma'am. Single or binary output.
Okay.
Thank you, ma'am. So now
Thank you, ma'am.
Now I call upon the paper ID 174 and efficiency of DCKSVM and HRBFNN technique for diabetic prediction. Authors are M. Shivaraman, Dr. J. Sumita.
I'm audible, ma'am?
Yes. Yes, you are audible.
Yes, ma'am. Thank you, ma'am.
Okay.
My screen is visible, ma'am? Ma'am?
Yes, it is visible.
Thank you, ma'am. Good morning to all. I am Sivaraman, research scholar, Dr. SNS Science College, Coimbatore, under guiding Dr. J. Sumita, assistant professor, Dr. SNS Science College, Coimbatore. Today I am going to present the topic and efficiency of DCK, SVM, and HRBF techniques for diabetic prediction. This is my agenda. First part is introduction, then objective, then relative work and materials and methods, and result and discussion, finally conclusion. First, so diabetic is a metabolic disease which occurs in the human body when the blood sugars or glucose level is very high. So sometimes the human body cannot create the insulin or any insulin, or cannot use the greater insulin in a proper way. So we have to classify it in three types of diabetics. The first one is type 1, type 2, and gastrointestinal diabetics. So the type 1 means where body cannot produce the insulin. The type 2 is the body is created the insulins, but not used in properly in our body. The third one is gastrointestinal diabetics. This is occurs only for the pregnancy period for women. So this is the statistics of diabetics in world level. The diabetes is also remarkable prevalent. According to the most recent ITF data, 537 million people, approximately 10% of all people aged 20 to 79 in the world were living in diabetic as 2021. This is expected to increase to 643 million by 230 and to 783 million by 2045. What more, an estimated 240 million of those who have diabetes are currently undiagnosed. So this is a graph representative of diabetic statistics. So this is the common symptoms of diabetics: frequent urination, blurry vision, increased hunger, excessive dyspepsia, and weight loss. So these are 8 risk factor of diabetics. So age above 40 and inactive lifestyle, high blood pressure, gestational diabetics, impaired glucose tolerance, abnormal blood lipid levels, BMI above 23 kg by meter square, and also family history of diabetics. This is the main 8 risk factor of diabetics. So we know that data mining is extracting information. And the main purpose of this research is to create a software for diabetic predictions. So I have used 2 algorithms. The first one is divide and conquer kernel support vector machine algorithm. The second one is a radial basic function neural network algorithm. So I am also used data BIMA Indian dataset, diabetic dataset for UCA machine learning laboratories. I have identified 3 main parameters. First one is accuracy and precision and recall. So I have considered best algorithm is radial basic function neural network algorithm. This is my literature survey for helpful for this research. So the data is BIMA diabetic dataset was obtained from the UC machine learning repository. So I am also using the KNN algorithm for pre-processing technique. So KNN nearest network algorithm. This is a new data point will be assigned the new value based on how closely they resemble the points in the training set. So this is the representative of KNN algorithm. So the divide and conquer kernel support vector machine algorithm. This is one of best classification method. So classify the data by using a hyperplane. Then using kernel trick, it maps the data from low dimensional space into high dimensional space to easily classify the data. This divides the problem into subproblems. So find the solution to each subproblem. Finally, it combines the solution of all subproblems to provide the solution. The next one is a radial basic function neural network algorithm. So this is a subfield of artificial intelligence. A human brain is having a neurons connected with one another. Neural network is also having neurons interconnected with various layers, input layers, and hidden layers and output layers. This is the main layers of neural networks. So we know that an input layer is set of source nodes. The hidden layer is high division of neurons. Then output layer is replay or output of the network. RBS is based on interactive learning process. Data example are applied into the network one at a time. Weight assigned to the input and are fed each time. The network learns throughout this space by modifying the weight at each time to predict the outcome. So I have denoted in 4 result. 4 types A, B, C, D. So A is true positive, B is false positive, then C is false negative, and D is true negative. So true positive is both diabetic patients and patients without diabetic are approximately counted. This is a true positive. Then false positive is determine the number of people with diabetics who do not have diabetics. And then true negative is number of diabetic patients and those without diabetics were computed wrongly. Then last one is false negative. It is to number of people with diabetic, even though they do not have diabetic. So this is the four parameters. So finally the result is we have to main three parameters we identify: accuracy, precision, and recall. So accuracy, the percentage of correct prediction for given set of test data is known as accuracy. Then also precision is indicates how of the instances those we were correctly predicted turned out to be positive. The last one, recall, the number of actual positive cases that are properly predicted by accurate model. This is a formula. The result and conclusion. Yeah, also DCK-SVM has accuracy of 73, 71, and 73 for accuracy, precision, and recall, which is lower than RBFF values of 95, 75, and 79 for accuracy, precision, and recalls. As the research, RBFF is the better performance than DCK-SVM. So it is proved that RPFF provides the better performance for predicting diabetic than exiting algorithm. So this is a chart for accuracy, precision, recall. This is the graphical representation of three parameters. So my conclusion is two predictor model are created for diabetic prediction using DCK, SVM, and HRBFN. BIMA dataset is issued from UC Miscellaneous Laboratory. Performance of those models are evaluated using the parameters accuracy, precision, and recall. So the result proves that HRBFM is good highest accuracy when compared with DCK-SVM. Future hybrid algorithm is created with different dataset of diabetic to improve the percentage of accuracy. So this is my references. Ma'am. Thank you for
Go to the comparison slide.
Yes, ma'am.
Previous, this slide. You have mentioned 95, 75, 79.
Yes, ma'am.
So what are the units for these values?
My data set values, ma'am.
No. You are showing accuracy 95.
Yes, ma'am.
73, and for that algorithm. So you are showing only numbers. I'm asking about the units of the values.
Yes, ma'am. My data set article is B minus data set. This is a pregnancy woman data set. We have some attributes, pressure and mass and variable pregnancy. We have values 0 to 17 is pregnancy attribute.
No. Here you are showing accuracy 95 and 73, precision 75 and 71. But these values belong to which unit? I'm asking about the units, whether it is percentage or any units.
Oh, yes, ma'am. Yes, ma'am.
I'm asking about the units of these values.
It's a percentage, ma'am.
That's right. But you need to
I
mention.
did not mention this percentage. Just on the 76, 71, and sorry for this, ma'am.
Okay. Thank you.
Thank you, ma'am.
Hi, where is this data set sourced from?
You see miscellaneous deposited, ma'am.
Okay, did we have the data set screenshot in the presentation?
No, ma'am. I have take a screenshot, ma'am.
Okay, so but it is a text data set, right?
Yes, ma'am.
What are the attributes?
Ma'am, some values have text and some values have numerical values, ma'am.
Okay.
Okay.
Thank you, sir.
Thank you, ma'am. Thank you, ma'am.
So now I call upon paper ID 183. The title is Bioinformatics and Machine Learning in Skin Cancer Risk Assessment and Prognosis, a review paper. The authors are Mr. D. Surendran and Dr. J. Sunitha.
Am I audible and my screen is visible, ma'am?
Yes, sir.
Yeah, very good afternoon to all. Um, I'm Surendran, research scholar from SNS Rajalakshmi College of Arts and Science, and also my research guide, Dr. J. Sumita, assistant professor from same college. In this presentation, I'm going to give the review. We are not implementing anything. We just reviewed the bioinformatics and machine learning concepts, which are which were used in previously to find or predict the skin cancer. This is the agenda for my presentation. First one is abstract and the introduction about cancer, skin cancer, machine learning, and informatics. And next one is this is a review of the different authors for bioinformatics and machine learning in skin cancer risk assessment, and finally the conclusion. First one is abstract. It is the skin cancer is one of the leading dangerous varieties of cancer, that it is caused by the unrepaired DNA in skin cells that produce the mutations or some genetic defects on the skin. It moderately extend to other parts of the body. It is if it is find in the initial state, we can easily cure skin cancer. It is required to detect as the early as possible. Practitioners in the skin cancer diagnosis in around 3 millions or more patients across the world. So need an early diagnosis to prevail any crucial conditions of the infected patients. The increasing rate of the skin cancer cases, high mortality rate, and expensive medical treatment requires that its symptoms to be diagnosed early. The bioinformatic concepts and some of the machine learning algorithm analysis relying on genetic, clinical, and histopathologic input have been increasingly used to risk stratify skin cancer patients with high accuracy. The literature review, we aims to provide a key genetic science drivers of malignant melanoma, that is skin cancer, and up to date applications of bioinformatics and machine learning models with the risk stratification of skin cancer patients. The robustly valid risk stratification tools will probably guide the medical practitioner management of malignant melanoma patients and ultimately improve the patient's outcome. We have referred many journals which are from the Google Scholar, Science Direct, and PubMed, and many other reputed journals for this review. Next one is the introduction about the cancer. So cancer is a disease which some of the body cells grow automatically and spread to other parts of the body. It starts almost anywhere in the human body, which is made up of trillions of cells. In general, human cells grow and multiply to form a new cells as the body needs new cells. When cells grow old or become damaged, they die and new cells take their place. Sometimes this regular process breaks down and abnormal or damaged cells grow and multiply when they shouldn't. These cells may form at tumors, which are lumps or tissues. This may be the cancerous cells or not cancerous cells. If it is a cancerous cells, it spread into or invade near tissues and may can travel to distant places in the body to form a new tumors. If it is not cancerous cells, it is a benign. The tumor do not spread into or invade nearby tissues. When removed, the begin tumors usually don't grow back, whereas the cancerous tumors sometimes will grow. The initial tumors can sometimes be quite large, and however, some can cause serious symptoms or be life-threatening, such as begin tumors in the brain. Next one is skin cancer. There are skin. It is a common type of cancer. There are three types of skin cancers: squamous cell carcinoma and basal cell carcinoma and melanoma. First two type of cancers are non-melanoma cancer, and second one, last one is named as a melanoma cancer. In a recent survey in the United States, in an every year, average of 5 million skin cancer patients are treated. As per the Agency of Healthcare Repository and Quality Medical Expenditure Panel survey, there are about 4.3 million adults are treated for different types of skin cancer. Especially the melanoma is considered to the most familiar type of skin cancer, which causes most of the casual death. As per the federal data for 2007 to 2011, around 63,000 US citizens are detected with the melanoma, and roughly 9,000 patients diseased on a year. According to the available data, the most of the melanoma spread was most common among the elders, and very less propagation among youngsters and children. The machine learning, introduction about machine learning and bioinformatics. The machine learning is the branch of artificial intelligence and computer science, which focuses on the use of data and algorithms to imitate the way that humans learn, gradually improving its accuracy. There are different type of machine learning, so supervised learning, unsupervised learning.
Sir,
And
can you please move to your contribution? These are
this
all
is my
known
this
things. You
okay,
move
ma'am,
to
this
your
is my
contribution.
contribution in the sense here we reviewed different papers from different authors, and also from bioinformatics and machine learning. The first author, Anjali Adal, who created a regression model for predicting the overall survival rate in melanoma patients. Those are affected. They are using the decision tree, lasso, random forest algorithms, and reach. And next author who developed a web server based Android application, that is the mobile application, to predict the survival outcome and risk of the melanoma patients. They are using the SVR, support vector regression based vector regression, that is based on a regression model. And another next author who had developed a multi-parameterized artificial neural network, which was used to predict and stratify an individual's risk of developing a non-melanoma skin cancer. They are using they are using the healthcare informatics data, and they are using the artificial neural network. And next author Denise Shevlin who has created a stable model which describing the formation and progression of melanoma at the level of molecular pathway activation. They were used support vector machine, random forest, boosted, and other many machine learning algorithms. Next author, Gogan Johnson, who have developed who have using and supervised hierarchical clustering and two group significance of microarray analysis and support tree analysis to find the different subtypes with the unique genes signatures which are associated with the different prognosis
Sorry for the interruption, sir. You have
Yes,
done
ma'am.
only the review.
Yes, ma'am.
Okay.
Yes, ma'am. We done only the review.
How many papers you have surveyed for your research work?
Ma'am, totally I've used 30 papers, but here I included only the 14 papers for the time conceptions.
Okay. Have you identified any machine learning algorithm for your work?
Yes, ma'am. We have not perfectly identified, but we have some partial conclusion. There are many authors using using the algorithms for Kalpan Mayer and SVM and random forest classifier algorithms for predicting and diagnosing the skin cancer. In that, among these three algorithms, the SVM gives the more accuracy in many cases. It gives the more than 80% of accuracy in many cases.
So what is the inference about the literature survey, sir. Almost you have completed your survey.
Yes,
So what
ma'am.
is the inference? Any idea to select the machine learning algorithm for your work?
Ma'am, all algorithms are do the perfect give some perfect result, but here we are the challenge for selecting the genes, that is bioinformatics variables. We have to find which informatics variable is um, give the correct predictions like that.
Okay, sir. Thank you.
Yes, yes, ma'am. Thank you.
Did we also look at the challenges in every of the approaches that mentioned?
Ma'am, sorry, ma'am.
Did we also go through the challenges that were faced in every of the papers?
No, ma'am. No, but
Okay.
I already learned some machine learning algorithm, but
Mhm.
the difficult part for me is the finding the bioinformatics variable. So we are in future, we are find the variables, bioinformatics variables.
Okay, so the main parameter we focused on every of the paper was the accuracy.
Yes, ma'am. Yes, ma'am.
Okay.
Here we are giving the accuracy of paper.
Okay.
Yes, ma'am.
Thank you, sir.
Thank you, ma'am.
I would like to thank our session chairs, Dr. S. Bhagavati Priya ma'am and Ms. Muthulakshmi ma'am for their valuable suggestions. On behalf of RIT, we thank you for making this event a successful one. Thank you, ma'am.
Thank you for the organizing team for giving me this opportunity to review the papers. Thank you.
Thank you, ma'am.
Thank you. Thank you to the faculty members and the college management and the team for having me here. It's a huge honor for me. Thank you.
Thank you, ma'am. The feedback link is posted in the chat box. Participants, kindly fill the feedback to get certificates. You can get certificates 2 or 3 days. Within 2 and 3 days, you can get the certificate. So feedback is mandatory for getting certificate. So kindly fill the feedbacks.
Ma'am, shall I leave the session?
Yes, ma'am. Sure, ma'am. Thank you, ma'am.
Okay, ma'am. Thank you.